Hello, and we're live. Oh, it's quite dark in here today. Oh, scary. Yes, it's getting that time of year where it's a little bit darker outside. Although the clocks go back tomorrow. Okay, thank you very much for joining me. This is Practicalli. My name is John Stevenson, and we will do some coding challenges today. So start off fairly simple. And actually, I don't think any of them are too difficult, but we'll see how my lazy Saturday morning brain actually works. Practicalli updates what I'm doing with the Clojurists together and keep on adding more and more content. This week I also fixed a bug in Cider for the new Clojure CLI tools flag, so that kept me busy. And just go on the web, yeah. And then we got videos. So I've been adding videos to the Clojure CLI tools to show how to use those. And last week we did a video on understanding kind of the flags and the differences, kind of migrating to those tools. I've been excuse me. I've done some updates in the Practicalli Clojure book. I've kind of reorganized this getting started piece, so hopefully it's a lot easier to read. And yeah, I also separate out the install to Clojure, my community tools, and then code analysis. So with CLJ Condo, just so it's easier to find those particular pieces. And also updated kind of the description on how to actually use Clojure CLI tools as well, and some of the built-in tasks, and then some of the common tasks that we covered in last week's video, in video 87, I believe it was. And then there's lots of ways to use the Clojure tools. There we go. And then, yeah, so if you want to reach out to me, then contact feedback, then it's very straightforward. Any of these channels will work, either a direct message or just general chat. You got a question in the audience. I'm wondering if I can convert a Luminous project to deps.edn. Yes, you can. You will need to create a deps.edn file in the root of your project. Let's just see where we got. So if we do Clojure do X new project, new templates. I want the template to be Luminous. Luminous. There we go. Then obviously this is going to create a project.crj file, and we want to basically have a deps.edn file. So if we look at the tree of this, let's go into the Practicalli let's go into my Luminous app. Now we can see that there's a lot of stuff there by default, but essentially it's got the we've got the M stuff. So you might need to include the M on the paths. You might need an alias, like a dev alias that includes ev dev. You do need to create something for project CLJ, like a deps.edn file for that. But the source, source and source is on source CLJ, so you'll need to include source CLJ on that and the path rather than that. So if we did a vim deps.edn, so we create a deps.edn file, then we need something like paths is it path or paths? I can't remember now. And you need source CLJ and test CLJ. So that's slightly different to how most projects are, and this is because I think it's because Luminous has both Clojure and Clojure script in there as well, so it's so the paths will be slightly different, and then dependencies. So deps. Oops. So this is a trickier bit because you need to copy in all the deps from here. So if we do, tree. So you need to copy in everything from project. So all these dependencies would need to be copied into. Oh, there's quite a lot actually, and it's a slightly different form, slightly different structure. So you need to put all these into a map. But it is doable. And then I think, yeah, so the source and test paths, you probably need to include resources as well in the deps path. There we go. So something like that. You need that in there. Oops. And then all the aliases. Anything else? The Uberjar, you just need some aliases for that, or you can use my Practicalli Clojure deps.edn thing to generate the Uberjar. And it's got things like Eastwood as well, so you'd need to have if you wanted to use those as well, you would need to include the linters, but again, they're all in the Practicalli Clojure one. There's a few things that might be missing. And then you'd also need to include for the env stuff, so the oops, I don't want to do it. So for yeah, we kind of need an alias, probably an alias for each of these, an alias for dev and prod and test, or an alias for, certainly for dev and test, that adds these paths in. So you would need, oops, I'm still getting used to using nvim, neovim. Oh, there we go. I didn't write it, there we go. So you would need something like dev and include the extra paths. Something like this, dev. Yeah. And then the same for test, but and then maybe have, if there's any test specific libraries that you want to include, you would also include those as a in the alias as well. So you know that's test. Oh, I can remember how to do things. Yeah, and then extra deps. Extra deps. And that should get you at least 99% of what lining, what lining is doing for that project. I think that's an interesting problem. I might do some, I might do a video on that specific thing. It's quite a good idea. Thank you, Ricardo. I hope that made sense. Oh, let's put the empty one in there. There we go. Then at least it'll write subs. No. There we go. Right, quit. There we go. There we go. I can use Vim. Yay, there we go. Okay, I hope that was useful. Cool. Let's see, where were we going? Oh yes, encoding, decoding. Excuse me, I'm going to cough for a second. Oh. I still have the cough, unfortunately, that I cannot shake, but hopefully it will not disturb us too much. Okay, where do we get to? Clojure tools. I'll go to that. Yeah, I think that's everything I was going to cover. So let's get on to the meat of what we were going to do today. And again, feel free to keep on asking questions, even if they're not related. I'm quite open to playing around today and experimenting. So let's see. So encoding, I've got the matrix here. We're not going to build the matrix, unfortunately. That might take a bit longer than I've got today. But encoding and decoding with Clojure, I think it's quite a nice introduction into transforming. You get this idea of transforming data structures from one to another. And so you're spending your time, often with Clojure, you're taking in some data and then you get some data out, some new data out, in either in a similar structure or a completely different structure. And there's a video I have on REPL-driven development that kind of finds the most common word that takes you through in one function. It takes you through several different transformations of data. And it shows kind of how to actually the different ways that you actually change the shape of the data in Clojure. And sometimes you do that just to make your code simpler as well. If you're finding yourself writing a very tangled algorithm for your function, then part of the problem is you might not have the data in the right structure, and because pretty much almost all of the 600 odd functions inside Clojure Core are geared up to manipulating or transforming data in some respect, then you've got a lot of tools to be able to put the data in the shape that you actually want, and then you can make a code a lot simpler just by doing a quick transformation, and then finding out the code is pretty straightforward. Good question in the audience. What is the best tool for using CLJ formatting and the current formatting standard in use? I think there is CLJ format, something like that, is fairly standard used. I think sometimes this is just built into a lot of the editors that you actually use as well. So if you're using a Clojure-aware editor, then it's pretty much, I think most of them have formatting already in place. If you're using any of these editors, they should just format the code as you're typing, or have a have a shortcut to be able to format that code as well. So you shouldn't need to have to explicitly format the code. When I'm using Spacemacs, it kind of just does the formatting as I go along. Although I think I have aggressive indentation as well, which helps formatting as I'm typing. But usually once you kind of press return, it'll format the lines as well, or you can just press something like tab to format the lines. Okay, so let's have a quick go at some of these. I think they're all complete, although I haven't been through these since I wrote them, so it'd be interesting to see if there's any other ways of doing things. So this is a very simple, so this is on the Practicalli Clojure book, simple projects, and then encoding, decoding, and we're converting booleans to false, from boolean true and false to 0 and 1. So in Clojure, a boolean value false and true, they're built into the language, but in a lot of other languages, or in kind of classic programming, it was kind of convention to use 0 for false and 1 for true. And I think you still get that in some command lines as well. So, so if you do a command on the command line, you might get 0 or 1 as the largely unhelpful kind of error message, but it kind of can sometimes give you an idea that that was false and 1 is true. So I'm going to create a new project. Just have a play around in here. I can play around in the editor. So where is the? Oh, that's what I was doing. I'm just going to create an app template in there. Whoa! Ooh, that needs updating. There we go. More homework to do. So we've got a project now. I'm just going to open that. Oh, did I? Oh, I should have. I put it in the wrong place, didn't I? Let's put it in the right place. Never create a project within inside a project. It'll get very confusing. There we go. So when I'm using Spacemacs, I usually create a layer. So I space LL to create a new layer, and then I've got a clean environment to start working on a project. That's not its projects Clojure study Boolean. And then I'm just going to open one of the files. I'm just going to open the deps file. There we go. I'll make this a little bit bigger. There we go. Oops, that's the wrong way. There we go. Boom, let's make that. So this is just a simple deps.edn file with 3 aliases, test runner and uberjar. And it's got the path. See, when I'm creating something with CLJ new, which is what I've just done, then it's just using source and resources, because that's matching the tree that we've got here. So we've got source practically and source test. I'm only using Clojure, so I don't need to differentiate between Clojure and Clojure script code. So that's why we've got the simpler paths. And then we're throwing in the test path when we're actually doing testing, because we don't want to include the test path when we wrap this up in an uberjar and deploy the application. That would be unnecessary stuff to include. Let's look at the source file. Boolean. There we go. We don't do a lot. Let's kill that then. And let's just do oh, my snippet's not working. Let's just do a comment and we can have a play. So we can do I haven't started my REPL. There we go. Oops, wrong button. That's the right button. There we go. I'm starting to wake up now. There we go. So this is just starting a REPL from Spacemacs, and then it connects to it as well. So it's just started an external REPL process and then connected to that process. So now I can just evaluate expressions. There we go. We see false is of type Java lang Boolean, and we're using the underlying types of Java to do this, because their Java lang Boolean is an immutable value, so you can't change it once you've created it. It would be a bit strange if you changed the value of true and false. That would get very confusing. So let's see, what was the challenge? So one useful way to start doing transformations is to define a map from one value to another. So hash maps are very common in Clojure, very good for defining values, but with some context. So here we can say like the false is the key of the map and its value is 0, and true is the key and 1 is the value. And so there's an association between false and 0 and an association between true and 1. And we can also look at this as a state transition as well. So we can, if we have a starting state of false, then the new state will be 0. If we've got a starting state of true, then the new state will be 1. So you can also conceptually treat a hash map as a state transition. And so that's also a very useful, simple way to actually manage going from one state to another. And so we can, what we're doing here, so we're using the get function. So if we've got this map, then we can get values out of it. So if we give it a value, then it'll give us, so if we give it a Boolean value, it'll give us the value from that. So we're just getting from this map the value that matches the keyword true, which is 1. This page is using clips, so you can actually go in and live edit the code. And if we get a value that's not there, then yeah, we get a warning. It's returning nil essentially, and you can get maps to return a default value as well. And then what do we got? Oh yes. So we can actually also, there's a bit of a shortcut. So get is taking a map and a key or a potential key in the map and returning the value if there's a match for the key, like we do with false. We can actually drop the get, which is a kind of an interesting a shortcut, an interesting condensation of the code. So here we're actually treating the map as a function. Excuse me. And so we don't actually need the get for this. Oops, let's go here. So create a map here. I cannot type today. There we go. True 1. And if we put, so this is a type. Oops. The type is just telling me what kind of class it's using underneath. As we're running on top of Java, then it's using Clojure types where, so it's using Java types where relevant, and then adding its own types on top of that. I'm just going to do space K and slurp to pull that in. So that's now an argument of type, the type expression. And you see it's actually formatting the code for me as I'm doing that as well. And we can see that's a persistent array map. But that's a Clojure type underneath. But we can just think of it as a hash map. And we can go in and so we can actually give it a name as well, so we don't have to keep typing in the map each time. Especially if we use a bigger map, then that's obviously really useful. Using the arrow is kind of a convention for name. Clojure is fairly flexible in the names, so you can just do an arrow, and this is indicating that we're going from a Boolean to a number. So that's quite an easy. Oops, I keep pressing the wrong buttons today. There we go. So this is so I've just evaluated this, just doing comma EF, and it's evaluated this. So this is now part of the running REPL process, and we can now use Boolean number, and you can see what it's showing us there is the fully qualified name of that var, that name that we've created, because essentially we just bound the name Boolean number to the map, and we're inside the Practicalli Boolean namespace, so that's its full address. So now we can just do actually just evaluate the Boolean to number, and you can see the kind of autocomplete has picked that up as well because I've evaluated it, evaluated the definition. So it's just a simple way to represent the map. And then, whoa, there we go. What else are we doing? So yeah, we can convert Boolean 1 and 0. We can also do a collection of those as well. So if we use the map function, so this is why it's kind of useful to have this. To drop the get and just use the map as a function. So here we're just using the map as a function, and then we can use the map as a function, use that concept with the map function. So the map function is taking a hash map. So I tend to call this a hash map, then we don't get confused with the map function. So this hash map is, we can use this as a function as we've seen here, and then the map is going to take each of the values in turn from Boolean values and put them into basically, so it takes each value in turn from this Boolean value, passes it to the hash map function as an argument, and then gets a result, and then map just pulls those in together. So there's the example. Yep. There we go. So here we're, let's make that be. There we go. So here we've got, so we've taken this function, which just happens to be a hash map, and passing it over true, false, true, false, true, false, true, false. And if we evaluate that whole expression, then we get ones and zeros in return. So we've basically gone from true, false, true, false, true, true, false, false, and so on, to ones and zero equivalents of that. And we could also kind of go in reverse if we take the reverse. There's a way to reverse a map, and so then we could translate back in from ones and zeros back into true, false, true, false, true, false as well. So I hope that was fairly simple to start with. And then what else we got? Caesar cipher. So the Caesar cipher, also known as rot 13, because you're rotating the characters by 13. We're doing so because there's 26 characters in the English alphabet. So if we rotate them by 13, then we get, it's kind of like, we always get like a different character for that. And so therefore we can create probably the world's simplest text encryption algorithm as well. Oh, so if we got this here as well. Oh yeah, that works. Yes. I'm using both styles of the CLJ new. We're going through a transition period between using what I used before, using the X flag, where we're passing in keys and values to the library that creates the project. Or we can do it more classical style, where we're just passing strings in here, but then you need to know that app, it represents the template app, and this represents the name. So I do prefer the X version. I might update that in the book, but it generates the same. Well, oh, no, it doesn't actually. What's there? Oh, yes, that needs to be updated because that should be project new. So I didn't have the alias. I need to fix that as well. There we go. So this got another project. Ooh, where did I put that? What did I call that, in fact? Oh, there it is. Okay. So let's go and have a look at that. Let's open study group. No. Right, there it is, row 13. And this is just the same as the previous one. There's nothing particularly different in this. So we've got the three aliases. I'm going to write my own template for creating apps as well. So there's a few tweaks I want to make. Essentially, you've got source, practically. I don't do a lot. There we go. Any questions? No questions. Let's see. So what are we doing? So here we're doing a similar kind of approach. We're defining an alphabet, and then oh, interesting. So we're doing an alphabet to use a basic conversion here. So we can create an alphabet. So this is basically our dictionary, our lookup of values. This is kind of like I think we're creating the keys for this. Oops. There we go. So we're kind of setting up. So this is the alphabet as a string. So we've got, and then we're creating a sequence of that. So it's going to create the individual characters. If we start the REPL. Oops, new project, new REPL. There we go. Now we can evaluate that. There we go. So a lot of the functions in Clojure core will just treat a string as a collection of characters. So when it's got the backslash in front of a letter of the alphabet, then that's representing a character rather than a string. So here now we've got rather than having a string as a value, we've got a collection of characters. And we can use these characters as the keys for the map. And then to generate the cipher, we can kind of create. We could just manually type it in and have it, but that's a bit time consuming and prone to mistakes. Here we're going to use cycle, which can create a lazy sequence of the alphabet. So it's going to go through each of the characters in the string and produce them, but we can offset that. So we're doing a drop. So we're going to drop the first 13 characters of there. So I think that's, yeah. So the first character would be N. And if we match that up with A, then we've got a translation from the A character to the N character. And then cycle is going to give us these values, but then going to keep on going around, because if we didn't use cycle and we stopped there, then we'd only have keys matched up to M that had like a corresponding value from the alphabet. But with cycle, then once we come to the end, once we come to the end of Z, then it's going to go back to the start and individually kind of return new characters from this in order. And then it will just, this would go round and round and round and round. So let's do this. Let's have a play with cycle. Let's do that in a comment block, because this isn't part of the code. This is just some experimental code we want to do. So we don't want, if we evaluate the whole buffer, we don't want to evaluate this. This is just code we're playing around with as we're experimenting and exploring the design. So if I evaluate cycle, I think it would just produce a very long results, and it's not entirely what I want to do. I only want it to produce a certain amount of values. So if I wrap that with drop 13, oops, I'm all thumbs today. There we go, drop 13. So that's going to drop whatever the first 13 elements are that cycle produces, and each element is going to be a character. So we can slurp that in. Slurp, bit of structural editing there. And then, even if we did this, it's going to keep on going on and on and on and on and on. We'd get a very long output. I think Cider would stop at 100. Let's just test out, see how good Cider is behaving today. We might need to stop the evaluation. Oh, there we go. So it stops that. So it's truncated the results, but you can see it's generating n onwards because it's dropped the first 13 characters. So A to M has been dropped. But it would keep on going on and on and on and on and on, which is not quite what we want to do. We want a definite stop point. So to manage that, we can specify some context in when we want it to stop, basically. So we say we only want to take 26 characters. We slip the rest of that into as an argument. So we cycle indefinitely through here, but we're going to drop the first 13, so we start at an offset point. But we actually only want 26 of them, and we get the alphabet offset by 13, and then we can then merge that in with the English alphabet above, and we've generated a map rather than typing it in manually, which takes about the same amount of time. So I think that's what we've done. Let's see. Oh yes, ZipMap. ZipMap. I never use ZipMap that much. I should use it more. Oh, and I've changed the name. Oh yeah, English alphabet. Oh, I made a foobar there, haven't I? That should be English alphabet. Nobody's spotted that yet. There we go. So if we keep that in there. So that should be English alphabet. Did I? I evaluated that. No, maybe I didn't. There we go, English alphabet. Yeah, having an editor that does autocomplete for you is quite useful. You just need to remember to evaluate the expressions when you're defining things, and then it should pick them up straight away. So here we're zip mapping two things. We're zip mapping the English alphabet we've got here. So this is a sequence of characters, and this generates a sequence of characters. And this is a sequence of 26 characters, and so is this. So we can just squish them together and put them in a map. And I've done something wrong there. What have I done? Oh, cycle. Oh, it's cycle alphabet. Oops, cycle English. Let's just delete words. There we go. Nobody spotted that. Maybe it's too quick. There is a 20-second delay, so I'll let you off there. There we go. So now we've got a map. That's a bit hard to read. So let's just check with Clojure.preprints and pretty prints. Let's just do that. Boop, boop. There we go. Oh yes, so that's going to pre-print into the REPL buffer. So let's have a look at the REPL buffer. There we go. Oops, too far up. So that's, yeah, so here we've got, forget that warning because that was, we've dealt with that. So now we've got A, the character A from the English alphabet is paired with, related to, has this association with N, which is the first one we've got from the take drop cycle combination. Boom, boom, boom. And we've got a matching number of characters and values. So we've got a very legal map all the way down to Z as keys and M as a value. So that's our map done. So we can kind of take this. Did I just give that map a name? I'll probably give that map a name. Oh, and we're doing it using the threading macro as well. So this is just exactly the same code. It just shows kind of the individual kind of transformations, and so it's showing them in the order that they happen. Whereas in the classic Lisp style, then it's showing us we kind of have to read this style inside out usually. So you would start with what it's doing. So we're going to cycle the English alphabet. We're going to drop 13 of those, the first 13 elements from that, and then we're going to take 26. Whereas if we put it in the threading, this is the ThreadLast macro, so we've got like a dash and 2 arrowheads. Then we cycle the alphabet. This value is then passed into drop 13 here. Oops. And then the result of drop 13 is then passed into ZipMap. And then the result of take 26 is then passed into there. And we should get the same results. What have we done? Oh, it's English alphabet. I'm going to have to fix that, aren't I, on the in the book. There we go. There we go. So it's the same code, it's just a different style of presenting it. So we can use either one. Let's go for the fancy one, just because I've got ligatures in my editor. I'm not sure what I called it in the book. Let's call it 13. And there we go. And these commas are just used as kind of showing you where the values go. Commas in Clojure are white space, so they're just ignored. So it's the same code. It's just a handy placeholder. Wait, I missed that. The commas. Why are the commas? Why the commas? So I was just showing you where each of the values would go. So when this ThreadLast macro is evaluated, it takes the first expression and will evaluate that, and then the result of that expression is then passed into the next expression as an argument. And because we're using the ThreadLast macro, it puts it in the last place as opposed to the thread first, which would put it into as the first argument. So they're just showing you where the result of the previous line ends up in the next line, and this is just a visual clue on how the code works. And it still works because for Clojure a comment is white space. I don't even know if it has a type actually. I've never actually tried this. I don't know what it does. No, it doesn't. So it doesn't exist. It's just for the humans, that one. And so I just use commas in this way to explain how it actually works. It's quite a handy kind of tool. There we go. And then what do we got? What are we doing? Oh yes, I was doing this. So what do I call it? Oh, and I've just put that into a let rather than a thing there as well. Ooh, I've done apply string. Okay, interesting. Okay, so we're just using this, right, okay. Okie dokie. Oh, copy. And so I've written, because it's a fairly small kind of expression, and we're only using it in one function, you could just put it into the function. So here we're creating a cipher. Basically, we can call it a cipher, we can call it a dictionary. Basically, the hash map that we're using to transform from one state to another, from one value to another. Here we're just generating that map, and we're giving it a name called cipher. So we're not actually using the def here. We're passing in the alphabet, which would be the English alphabet, and then the text that we want to generate, and then we generate the hash map to do the translation, to create the cipher, and then we actually apply that cipher to the text. And so we're going to go through the text and replace each of the characters of the text with its cipher. So basically, let's do that. Let's do an example of this. Let's call this, I keep pressing the wrong button. There we go. So if we call this rot13, and we pass that an alphabet, which is going to be the English alphabet, and a text to generate the, this is a thing that we want to run the cipher over. Let's do something simple. And let's just walk through this. Do I want to walk through this? Yeah, we give it a try. Boom, boom, boom. So I've just instrumented this function, which puts in a whole bunch of breakpoints. So it'll step through each of the things that we wanted to do. And if we evaluate that, then we can see what's happening. So we passed in an alphabet. And then the next step, we're going to cycle that alphabet. I probably want to I've killed it now. Oh yes, might be doing an infinite loop there. Let's try that again. Boom. Oh no, I've broken it. This is what happens. Yeah, I evaluated cycle alphabets. Now it's generating like an infinite number of results, which I didn't really want it to do. How do I kill that process? So I should have stepped over the whole cipher thing. There we go. I'm just going to have to evaluate these things. Again, there we go. We're back in business. So let's just see if this works. Oh, come on. Come on. Oh. It looks like it's the right shape because the two L's are converting to the same character, so it looks promising. Obviously, if I'd written some tests, that would have helped as well. That might be a nice little add-on to this challenge, to write some tests to have some phrases to convert. So let's just try this again. Oops. Let's put the debugging on. Yeah, what do I do? Oh yeah. So I've instrumented that. Let's skip over that. Is that going to work? There we go. Next. No. I keep breaking it. No. Let's not do that then. Because it's still evaluating. I think it might be evaluating drop 13 over cycle, so it's still going through the cycle. What I will do is change this. I'm going to put this into the comment. Boom, boom, boom. I'm going to change this to use the def here. So I'm going to pass in. So instead of passing in alphabet, I'm going to pass in the cipher. If I can spell right, cipher. There we go. And so I'm going to kill the let, because no, not the let, not that let. I'm going to kill this. There we go. I don't need this, and I can raise this space K. We'll just replace the expression above, so it basically gets rid of the lets around the apply string. And so now this is a much simpler function. So what we're doing is we're going to pass in this English rot13, which is a cipher, and that'll help me step through the replace thing there as well. So if we evaluate that, so instead of doing this English alphabet, we can do rot13 with the English rot13. So that's the actual cipher we've generated, and then just the text. Hello. Get rid of that. Did I? Oh, I didn't start there directly, and there we go. You have to be a little bit careful with lazy evaluation. If you evaluate things like range and cycle without any context of when they stop, they don't stop. And so they're basically generating, they're infinite sequence generators, and I don't have a computer that can hold infinity, so it's a bit tricky. So let's just do this again. Boom, boom. Fun. Yeah, so we're getting the same results. Can I step through this? Let's just try this. I'm not sure if it will work or not. Let's have a look. Oh, cipher. So that's a cipher that's generated. So that's the thing from the English to rot13. We're taking hello, and it converts it basically into the characters. So we're replacing each individual character using replace. So replace is a bit like a map specifically, but it's specifically taking the cipher, which is a function, which is a hash map that acts like a function, and applying that to the text, and it's generating a sequence of characters, but we actually want a string, so we're using apply string to stick them back together. Although this isn't entirely idiomatic, so we really should use, it's a better form to use the Clojure.string, string library, which is part of the standard Clojure library, and we do, I think it's join, yeah, and you can do join with or without an argument, I think. Yeah, so you can do join as a collection. So if you see down the bottom here, we can do join just with a collection, or we can also put in a separator as well. But we specifically want to join things together here. So if we do that now, yeah, works exactly the same. It's just that's more a usual form. and then we should put that in the thing as a require. Clojure.string. There we go. Yeah. Or we could even do that as an alias as well. There we go. Boom. Okay. Ooh. Popular today. There we go. Let's have a look. Yeah, I think that's everything I covered on here. So there's a couple of mistakes in there. What do we do for RNA? I think this is very similar actually. So it may sound a complex subject, but converting DNA strands and returning its RNA complement. But essentially it boils down to the fact that there's this conversion that is specified. So this is an example from the exorcism, exorcism.io, exorcism.io, which is a nice, you can go on, there's a Clojure track and there's lots of exercises here you can do. And you can also request help from mentors as well. So they'll give you advice on the solutions that you post and give you some support that way as well, so it's quite useful. So this one boils down to the fact that we're, oh, this has got tests as well, so this has got tests here. So we're going to test, see, are we converting individual characters correctly, and are we converting the whole string at once as well. And if there is an error, then we're throwing an assertion error, which is kind of unusual. We don't really throw that many errors in Clojure. We don't usually have them. It's usually just missing data or data that we don't expect. But you can throw, you can explicitly throw errors as well if you want to. And so this one is if we pass in a character, in this case, if we pass in X, X is not part of the, it's not a legitimate DNA strand or RNA strand, so we would throw an assertion error to say, we've got some bad data there. And in this example, we are pulling in Clojure as a string. We're doing that straight away. We've defined our map. We've just written this out directly because it's just a sort of small map. There's no kind of need to generate this. If there was a lot more complexity in that, then we could generate it as well. So here we've just defined a name to represent the map, and it's also useful to add in a string just to describe what it's doing, especially if it's not kind of obvious. And then I've got a function which converts a specific nucleotide. So here we're taking in a dictionary, which is this RNA, DNA dictionary, and a specific value. So this will be either G, C, T, or A. And it's converting it to a string, because when we're actually going over the whole sequence, then so we're going to map over the whole sequence, and map is going to treat each nucleotide as a character. So we just convert that back into a string, and then we can use that to match the strings in here. Or we could have just written these as characters. Might have been actually easier, and we got rid of the string there. And so here we're checking to see if the string in the sequence that we're passing, does it contain X? And if it does, then throw an assertion error. So we're just basically checking over the whole sequence to make sure that there's no errors in there. Although this is only checking for X, so this is a bit of a simplistic check. And I think I've done a better version of this. Yes, that's me just switch to the, I'm going to update that, I think, because there's, if I go to exorcism, there we go, and we open RNA transcription, which is what that exercise is called. This is just let's go to the source, RNA transcription. Oh yeah, so in this one I've used characters instead, so this is much simpler. I think I'm going to update it to this one. And what we're doing is we're actually, rather than processing the whole string first to see if it's got like bad characters in this example, we're only really checking to see whether X is in there. But if we've got Z, that's also like an illegal character, even though it's not part of the tests. If we were using generative testing, then it'd be a lot easier to define some tests where we kind of just generate this sequence each time from a specification that just includes GCFD, and then we could have like a bad specification that's like invalid DNA, and we could use that to generate different invalid characters to see if our code picked those up. And this one would not pick those up unless they were X, whereas in this example what we're doing is as we're mapping through our DNA nucleotide, let's just start, then we're either going to find the character in the map, so we're either going to find the key. So if we've got GCTA passed in, then it's going to successfully carry out this expression, because it's going to be able to convert. So like if we passed in a G, then it would be able to convert that to C. But if we passed in an X or a Z, then this expression would return nil, and nil is a falsy value. It's like a false value. So this part of the OR is not true. So OR is basically there as like is something true or false. And so if the first thing is false, which it is because we're returning nil from this, if we don't find a matching key, then we can throw an assertion. So as we're going through the string that we pass it into our function, then it's going to pick that out, and if it's not a key in the map, then it'll this will return nil. So then OR knows to go and do the next expression, and it throws an assertion. But if this finds a key in the map, it's going to return the value, and that value is going to have like a truthy nature to it. So OR is going to say, okay, I've got a true condition, so I don't need to go and do any more parts of I don't need to run this extra expression here. I can finish what I'm doing because I've got a true answer. So OR is a macro, so it works slightly differently. It's a bit like if, it will kind of stop as soon as it gets a true condition. So if we evaluate this, so we've got the dictionary, we've got the conversion cipher to convert it, we've got the function to do the conversion, and then we can call it. So if we call with legal characters, then it's going to be okay. Let's just try the, oops, no, let's do that. Let's instrument it again, put some breakpoints in. See if we can do this without breaking the REPL. So we're passing in to DNA here. This is the string that we passed in, and then this this map function is taking this function. This is like an inline function, and it's for OR, and so it's either going to be, so map's passing in the individual characters from this string that we passed in turn, and it's passing it to this DNA to RNA function. So we're passing in G, and that finds a match in the map, so we would get return C, and we don't need to, and then we can skip over the throw expression and go round and 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 round, and we get the result. And so then we're just using string join to put them back together again as a string, and that works. But if we call, let's see, if we call GX, then that's what we're passing in. So the first one is working, so we happily use the OR, and so we skip over the throw. But the second one is using X, so it's returning nil now, and so nil is false. And we get our assertion error that's thrown, and it's throwing us some details. And here we can see the message unknown nucleotide, so we know it's thrown that thing there, and then we get the message inside. So that's quite a nice evolution of the design that works quite nicely. So this isn't my first, I think it's my third or fourth iteration of the solution. So sometimes it's worth revisiting something and thinking about how you can kind of finesse the code a little bit more as well. And it also helps you use different parts of the Clojure core as well. I'm starting to use OR and more. I didn't used to use them to start with, but they are very useful for controlling which bits of code are actually run. Okie dokie. Well, we've covered 3 out of 4. That's pretty good. And then, add unit tests. That's a note for me to do. And there's this other one you can go and have a play with as well. This is very similar, except we've got this idea of passing messages as lights, as a light sequence. So each character here has a sequence of lights. This is from the Terry Pratchett's Discworld books. If that's something you've read before, you might recognize this. But basically we've got an encoding for each character, and then we can use that to encode a message at one end, and then we use the lights to transmit it over a continent, and then we can decode the encryption or the light pattern and retrieve our message. So we can represent the lights as here we've got like a vector of vectors, or we could just have a simple vector. We don't have to match the exact kind of shape of each of these lights. We can use kind of like whatever makes sense as an internal representation. Here I've kind of tried to keep it the same as the domain, the space we're working in. And then written some tests for that. And basically come up with this, I think initially I started using keywords. There is a slight problem with keywords, is that you can't represent a space easily with keywords. And so I think I ended up doing this classify thing. So if there's a character which is classifies, yes, classifies taking a letter, and we're turning that into a keyword and then finding it in the alphabet. So I do use keywords a lot in maps, but sometimes they're not the right kind of shape of data you want, and not the kind of thing you want in here. And using, again, I think using characters for this is probably an easier approach, because it comes down to exactly what you're doing. If you're processing a message, you're going to end up turning that message into a series of characters. And so if your map uses characters, then it's going to be a lot simpler. So I think I'm going to rewrite this challenge. But basically I've got a classify and a declassify, because the light patterns are to do with the class system. That's what the system is called, using the light patterns. But again, it's essentially the same. You're ended up coming up with a sequence of light patterns, and each of these vectors is representing a character. And a useful thing I think I did, I don't know if it's represented in here, when I created the map, when I created the map, I didn't create the whole map because I wasn't quite sure on the design I wanted. And so then if I'd have done it for the whole alphabet and then I decided I had to change it, then I'd have to change the whole alphabet. So sometimes it's worth just creating a partial kind of dictionary, a partial cipher, and then testing that out to see if it's the right kind of shape, the right form. And then if it is, then you can kind of keep on building it and fill in the whole alphabet. But I'm going to leave that for homework for both of us and see if we can come up with a better approach. This works really well. Oh, this is an interesting thing to do. So if you want to declassify something, there's this very nice function in Clojure set, which is called map invert, which strangely inverts a map. It does what it says in the tin. It basically switches over the keys to be the value that they're associated with, and then the value becomes a key. So it's a very handy way of generating something. Let me show that's in here. Yeah, so if we do Clojure set, I don't think, yeah, it's part of the, it's part of the namespace already because it's showing up in my autocomplete. And so if I pass in DNA, type, so therefore, yeah, so it swapped it over. So you can see it swapped G and C over, and C and G over. That's a bit confusing because they're similar. But it has basically inverted the map. And so rather than having two different maps, we can use map invert to swap the keys and values over. So we've got a decoder as well as our encoder. So this is using, here we're using the map to encode, and we can use the inverse map to decode. And woo, we're way over time now, aren't we? Oh, well, this is fun. I hope you all enjoyed this as well. And one thing to note is I'm using, I think in all of these examples, I'm passing in I'm not in that one actually. Oops. Was it? I think, and I did it in the other one. Oh, sorry, it was in here, wasn't it? In Rot 13. So in Rot 13, I'm passing in the cipher explicitly, which is a useful thing to do because if we're just using we could just use the cipher for that's shared between all the functions. But if we design our function to specifically include the cipher as an argument, then obviously we can pass in different ciphers and make our code more generic as well. So that's a useful step. So I think that's something else to make sure that I need to do with RNA and DNA, like make that more generic. That'd be quite nice. Alrighty, well, it was good to know that I could still do some coding, so that's good. I still know how to use my editor. Okay. If you've got any more ideas on encoding and decoding, I think there are more involved encoders and decoders that we can add there. If you've got any ideas on that, then let me know. Feel free to kind of share those ideas in the in any of the channels that we've got. There's so many channels, so many different ways to communicate. And you can also send me a direct message in any of these channels as well if you're if you don't want to share publicly. Alrighty, I'm going to leave it there. Thank you very much for joining me. Where's the right button? There we go. Oh, my hair's still messy. I'm going to go and sort my hair out. It's messy. But thank you very much for listening and everybody's support and continued watching of these. And I will keep on doing them as long as people are interested in seeing them. Okay. Thank you very much and have a wonderful weekend and next week. Goodbye.